All right, let's dive in. Imagine for a second a place where gravity is so intense, so powerful, that it actually swallows light itself. Today, we're taking a journey right to the edge of what we know, to demystify one of the universe's biggest and baddest enigmas, the black hole. You see it in movies all the time, right? Science fiction loves to picture black holes as these cosmic shortcuts, these amazing gateways to other dimensions. But if you peel back all that Hollywood fantasy, what's the real science say? Well, the reality is, it's a lot more final. And honestly, it's way more terrifying. A black hole isn't some kind of doorway. It's a cosmic trap. It's a one-way ticket to, well, oblivion. Yeah, this is the point of no return. We're talking about a place where gravity isn't just another force, it's the absolute law. The pull is so insane that the very fabric of space and time gets all warped and twisted, creating this bottomless pit in the cosmos that nothing can climb out of. Think about that for a second. The fastest thing in the entire universe, light itself, cannot outrun this thing. That's why they're black. It's not just dark, it's the ultimate kind of darkness. It's where light goes to just disappear. So physics this extreme kind of sounds like something out of a nightmare, doesn't it? I mean, how does the universe even cook up something so monstrous? Let's take a look at the wild birth of a black hole. For a long, long time, black holes were just this weird mathematical curiosity. People thought they were basically a joke, hiding in Einstein's equations. It wasn't until 1971 that we actually found one, Cygnus X1, and proved these cosmic monsters were very, very real. And then, in 2019, humanity did the impossible. We actually took a picture of one. Incredible. So here's the most common recipe for making a black hole. You start with a truly enormous star. When it runs out of fuel, it collapses under its own massive weight, and then it goes out with a bang, a supernova, an explosion so bright it can outshine an entire galaxy for a little while. What's left behind is the ghost of that star, a stellar black hole. But here's the thing. Don't assume all black holes are created equal. Oh no. The universe has a whole catalog of these cosmic beasts, from the kind of small to the truly, truly mind-bendingly huge. So we've got four main flavors. There are miniature ones, which might have been born way back in the Big Bang. They can be the size of a single atom, but weigh as much as a mountain. Crazy, right? Then you have your stellar black holes, the common type made from supernovas. And then you get the giants, the mysterious intermediates, and the colossal supermassive black holes that basically act as anchors for entire galaxies. And yep, you guessed it, we have one of those giants right here in our own cosmic backyard. The whole Milky Way galaxy is spinning around a supermassive black hole at its core. Its name is Sagittarius A star. And believe me, supermassive is an understatement. Sagittarius A star is 4 million times more massive than our sun. It's the gravitational heart of our galaxy, pretty much holding the whole thing together. Okay, so let's just indulge in a little bit of cosmic horror for a moment. What would actually physically happen to you if you took that one-way trip into a black hole? Yeah, you can forget about a quick and painless end. The gravity at your feet would be so much stronger than the gravity at your head that you would literally be stretched apart. Scientists have a name for this, and it's grim, but it's super accurate. They call it spaghettification. You just become a stream of atoms, a long, thin noodle of what you used to be. And if that isn't weird enough for you, time itself would completely break. To your friend watching from a safe distance, you'd seem to slow down and just freeze at the edge of the black hole, like you're stuck there forever. But for you, the entire universe outside would flash forward. You'd see its whole future play out in an instant. But wait a minute, if these things are perfectly black, if they swallow light, how in the world do we even know they're there? How do you see something that's literally invisible? Well, we don't actually see the hole. We see the cosmic car crash that it's causing. As a black hole devours stars and gas, all that material heats up and forms this brilliant, swirling disk of light around it. It's like a final scream before it all gets consumed. That accretion disk is the telltale sign we look for. And the edge of that dark abyss, that's the event horizon. It's not a physical wall or anything. It's a threshold. It's the point of no return. Once you cross it, the laws of physics as we understand them guarantee you are never, ever going back. And it's just amazing that we've built these incredible eyes to watch this cosmic drama unfold. telescopes like the James Webb, parked a million miles away from Earth, are so powerful they can detect the faint whispers of light from the very edge of these cosmic monsters, light years and light years away. So, we've explored the what, the how, and the where of black holes. But there are still a few really big questions that linger, especially about our own little neighborhood in the universe. All right, let's get to the big one, the one everyone wonders about. Could our own sun turn into a black hole? Thankfully, the answer is a very comforting no. Phew, our sun, it's just not big enough. It's a pretty average star. In about 5 billion years, it'll swell up into a red giant, and then it'll fade into a tiny, dense white dwarf. It just doesn't have the sheer mass needed to trigger that kind of catastrophic collapse. Okay, so we know the rules, but are there any loopholes? I mean, really, once you've crossed that event horizon, is there any conceivable way to get out? As far as we understand the universe, the answer is an absolute, definite no. To escape a black hole's gravity, you would have to travel faster than the speed of light. And the laws of physics have a very hard and fast rule about that one. It's impossible, full stop. And that leaves us with one last, delicious paradox to chew on. If a black hole is a cosmic one-way street in, could there be a one-way street out? A theoretical white hole that just spews matter out into the universe? We haven't found one yet. But, in the search for cosmic truths, sometimes the questions are even more exciting than the answers.